So in this session, we'll be looking at advancements in utility inspections through drone technology, the transition from traditional methods to innovative automated drone inspections with that emphasize efficiency, safety, and cost effectiveness. The sleep and technology offers a streamlined approach to utility asset management, enhancing operational reliability and safety standards. And who better than Gresco team to talk about it? Gresco Technology Solutions, established in 2013 as a part of Gresco Utility Supply Incorporated, specializes in UAS and telecom services and equipment. Based in Forsyth, Georgia, with 7 locations across the Southeast, GTS offers comprehensive unmanned aircraft system solutions in US and Canada. Leveraging Gresco's 60-year legacy, GTS provides latest drone technology backed by Gresco Utility Supplies' extensive resources and knowledge. And today we have with us Jim Baker and Nathan Hayes from the Gresco team. And I have also had a great opportunity to work with them for a short period recently. So great to have you, Jim and Nathan. So let's have a quick round of introductions before we begin. So Jim Baker is the Southeast Account Manager at Gresco UAS, where he pilots his role with same expertise and zest he once did with drones in law enforcement. After 3 decades of serving and protecting, including decade at the helm of 32 aircraft, 30 drone pilots operations unit. Jim took his challenge to Gresco about a year ago. His toolbox is packed with skills and in drone inspections, operations, policy making, and rescue missions as well. Now he's also navigating complex skies of BV laws. When he's not charting new territories in drone tech, Jim is the family co-pilot navigating life with Jamie and his co-captain of 29 years, and their crew, Jimmy and Jordan, who are studying at University of Florida. Along with Jim, as I said, we have Nathan Hayes. Nathan, as Gresco's US support specialist and support operations and product specialist, has been an instrumental part of the team since 2017. With 7 years of experience in the SUAS industry, Nathan exemplifies an exceptional understanding of the product line and provides an invaluable support to customers. His meticulous attention to detail and guidance through dynamic realm of ever-evolving drone technology is an exceptional service to their customers. And his forward-thinking approach has been instrumental in advancing the mission and transform the UAS market. Now, I would like to briefly address the audience with a couple of housekeeping rules. Please send us the questions. Be extremely, free and curious. Just put out your questions in the Q&A tab, and Jim and Nathan will take it up towards the end of the session. And along with that, the session will be recorded and will be available on Flight-Based TV along with social media platforms. Gresco also has a booth in the expo section, so do check it out. You can visit the booth and also get an opportunity to interact with the Gresco team. Now, goes without saying, you will learn some invaluable insights from today's session. Just go to the LinkedIn and use the hashtag NestGen, and there's a surprise for you. The top 3 posts will win a NestGen hamper. So just go to LinkedIn and use the hashtag NestGen. Last but not the least, I would like to thank our sponsors for their unwavering support throughout this event. Title sponsor DJI Enterprise and our gold sponsor Sunflower Labs. Over to you, Jim. I'll just quickly stop sharing my screen and pull up the presentation.
Great. Well, thank you very much for having us here today. Over the next 15 minutes or so, we're going to go down this road, and we're going to talk a little bit about where we're at. We're actually where we've been, where we're at, and where we're going with all this. So it's going to be a brief, high-level overview, but we're going to see the gamut and see if we can talk a little bit about all the advantages to try to reach our goal, because the goal is where we need to be. But why is it so important, and and explain the need to get there. So the first slide is in reference to traditional inspections. So in the utility space, where did we start with all this, trying to evaluate our equipment and try to take care of it, maintain it? So first thing we had was the old-fashioned line crawling. In the old line crawling days, literally they would crawl along the power lines to inspect it to make sure there were no frays, make sure there was no damage, anything like that. Of course, then there was ground-based inspections. Ground-based inspections simply used, telescopes, binoculars, cameras, any type of optics. In when they were lucky in the old days, sometimes it was just about just your your vision. And so obviously from the ground, trying to look up can be very challenging. You're only seeing one angle, you're not seeing anything from the top, and hard to see from the sides, but you're only seeing the underside of the apparatus. Then we got into bucket trucks, and bucket trucks helped improve the angles, but then you start getting into additional crew members for these inspections because it takes ground crew with the bucket trucks. Of course, there's a lot of safety concerns with bucket trucks. We'll talk about that here in a few minutes. I've spent some time in a bucket truck and had some scary times in a bucket truck, so we'll talk about that in a minute. With using a bucket truck apparatus, there's downtime. There's times between relocating the apparatus and being able to inspect. There's a lot of downtime, so we want to prevent downtime. That's one of the goals here. And then there's manually climbing poles. I can remember when I was a kid seeing the wooden spikes and all the power poles, all over the neighborhood. And it wasn't very, very common to look out and see a lineman or someone in the power industry climbing up those spikes and those old wood poles. But these methods, while they were effective, they were slow, very slow. It increased the downtime in the power when they had to de-energize, things like that. And of course, manpower. And manpower is certainly expensive, and sometimes there's a shortage of it. You just can't get enough and can't get enough people to do it. So manpower is definitely a problem. In slide 2, we're going to talk a little bit about the challenges and how to prevent the power outages. And we already mentioned it, but the increased downtime. When the power goes down, people aren't happy. We're definitely relying on electricity around the world, and that's also dollars, though. Power companies, utility companies in general, whether it's a telecommunications utility, whether it's water, whether it's electric, whatever the case may be. When the electrons aren't flowing, or the water's not flowing, or the light's not flowing through the fiber, they're not generating revenue. And we're all in a business where we have to generate revenue. So we need to make sure that we decrease that downtime as much as possible. And a lot of that is by having great proactive maintenance. And then cost, as much as we try to give the best value to our customers. We have to be able to cover our costs. We have to try to reduce costs where we can. We have to be good stewards of our customers' money. We have to provide them the best product at the most reasonable price. And so by being able to reduce personnel, reduce equipment, and reducing resources it takes to do these maintenance missions, we're able to pass those cost savings on to the customers. And service reliability and reputation. So that is huge in all industries and in really all business. When you can't provide your service and people start getting frustrated with you, your reputation goes down, and we never want that. We've all had problems with different utilities that when you're in a group of people talking, you don't always hear good things about some utilities, and we want to change that. We always want to make sure that we're treating our customers as best as possible and giving them the best product possible. Climbing a pole, climbing poles is a challenge depending where you're at, what you're doing. I couldn't imagine climbing a pole up north in the middle of the winter. I'm a Florida boy, so it's always nice and warm in Florida. Just the hazards of climbing poles in general, let alone, at least in a bucket truck, you're usually insulated. You're not insulated on a pole. In different weather conditions, certainly not the best thing to do. And there's always the risk of shock, being shocked. It's not like if you're at your house and you grab the plug wrong when you're pulling it out of the house and you get a little shock. When you're up on that pole with, hundreds of amps instead of that 15 amp circuit, things can go really bad really quick. So that is certainly a danger area in the industry. Bucket trucks, bucket trucks themselves can be very dangerous. I spent a lot of time in a bucket truck in my past career, and just being on the side of the road with traffic coming at you, and I actually had someone take out some cones headed to the truck one day. Didn't hit the truck, thank goodness. But standing up there and in that bucket, looking down and seeing those cones go flying in that car was a harrowing experience.
Yeah.
And
And
so
Jim,
I would hate. Yeah, go ahead.
yeah, with bucket trucks, like we were talking about. So, like, how did you feel like it would be like, even though all the safety precautions out there, what like you still had some concerns, right? Like,
Oh, absolutely. We had cones in the road, we had flashers and markers, and it still happens. We've all seen the videos on YouTube where people, sometimes people don't drive the best and or make mistakes. We're all human, and so bad things happen. And so, getting the man out of the road, the person out of the road, is certainly a benefit whenever we can, and the UAS industry can
right.
certainly help with that.
All
The
right.
next slide, talking a little bit. Oh, okay, good.
Yep.
Okay, so for the traditional method of drones, so we've now jumped from our terrestrial, ground-based inspections, whether it's truck or climbing or whatever, but back in around 2016, 2017 with Part 107 jumping in. That's when drones really first started being prevalent in our industry. Before then, there was some drone usage, but it wasn't that common. And after 107 kicked in, especially after a year or two, when we started figuring it out and figuring out the safety precautions and management systems and everything like that, we started getting a lot more prevalence. But there was also challenges with that as well. So yes, sure, right off the bat, we started getting these great views from up high. We started seeing tops of poles that we hadn't seen before from the ground, without having to be in the truck. But then we started having challenges with data management. So what do you do with this data? Quick little story is I was part of the recovery effort after Hurricane Irma hit Florida in 2017. I can tell you to this day, there is a hard drive with over 1 terabyte of data that has probably never been looked at because nobody knew what to do with it. We went out and we were shooting 4K video, and it's just these massive files. They couldn't be emailed, they couldn't be transferred. They're on this hard drive. What happens? And so we've learned a lot since then, how to manage that data, what data is necessary and what data isn't necessary, and what's best for the operation. And then once you start working with that data, what happens at that point? So now you've got more complications. One, if the right type of data wasn't archived, then there's a lot of challenges on the analyzing side of it to try to extrapolate the data needed, or they just don't have the data they need. And of course, then we start talking about having to hire third-party people, third-party companies. So while you've saved manpower on one side, increased safety on one side, it's very easy to now increase manpower on another side. So kind of more shifting than replacing. So again, we want to save costs. That's the end goal here. And getting to that autonomy is where we truly start saving the cost. So let's talk a little bit about the actual automated drone inspections on the next slide. We're finally approaching an area of fully automated drone inspections, although there's still some challenges, some big challenges. But the benefits of the automated drone inspection, are huge. But the key is to be fully automated, not just automating part of it. We've had partial automation for a long time. It's that full automation is where we really start getting the benefit. The thought of collecting it without the pilot. So we need to be able to set these boxes up, set these drones up, and hit a button or just put it on a schedule, and that drone automatically collects it without that visual observer and without that pilot. We need to get those people to doing other jobs, other things that are very important in the industry. They can still be doing those while the automation is taking care of it. Then the key is to get it to the cloud. So getting it to the cloud is getting it to where it can be analyzed and where it can be worked. And that can be done through a lot of different challenges. During the flight, we can use cellular networks. After the flight, we can use whether cellular, get back into a terrestrial base. Starlink is coming. Starlink is definitely going to be our friend in this automation industry, because in areas where we don't have that connectivity, that technology, especially where it's going now, it's good now. But if you look at the forecast of what Starlink's going to do, it's going to become exponentially better very, very quickly. So we need to kind of shift our mindset away from traditional siloed databases into these cloud platforms that can, again, autonomously upload, autonomously evaluate the data, and autonomously generate reports to where we can see where the data is at, or see the results of the inspection. And that reports side of it is where we really start seeing the benefits of this automation, where it can be auto-generated as well. Let's talk a little bit on the next slide about the benefits of drone inspections. Of course, there are many immediate benefits of drone inspection. Again, go back to kind of that first thought process we had of minimizing downtime. Reduce the number of outages. Again, that's money. That's not serving our customers the best that we can when we're down. So that increases higher reliability, better reputation, the things that we've already talked about. And so for the residential customers, commercial space, that's of course what we need to do, where we need to be. And we also looking at, we want to reduce all the utilities, or I'm sorry, reduce the O&M costs for the utility. Utilizing the overhead and passing the increases on to their customers, the maintain regulatory compliance is going to be a huge part of this as well. The regulation side is going to be one of our biggest challenges, because industry a lot of time outpaces the regulators, so we see it now. We're going to continue to see it in the future. But it's getting better, of course, but we still definitely have those challenges. And of course, safety. It all comes down to safety in the end. So end-to-end solutions. Let's talk a little bit about end-to-end solutions on the next slide. The goal is to have an end-to-end solution in regards to automated inspection. Requires the entire process to be automated. We've kind of been touching on this, but from the information that's being requested all the way through the report that's being generated. It all starts with requesting the proper information also. If you go back to my story with the, after the hurricane, we didn't know what to take. We didn't know what was needed. In hindsight now, in our rearview mirror, we know that 5 images of a disaster area or something that has been destroyed in the disaster is really all that's needed. 1 nadir shot and 4 obliques, and that usually gives all the information needed to those that are evaluating it for storm restoration efforts, emergency mitigations, those type of things. So knowing what to do is and what to ask for is huge, because no one told us what they needed after that storm. So we just assumed they wanted the best quality video they could get, and that's really not what they wanted or not what they needed. When the asset's remotely being inspected, data is being collected, of course. Data is collected in a central resource and then uploaded as a digital twin, inspection AI algorithm in the base software. So you hear this term a lot, digital twin. And these digital twins aren't just for the disaster recovery or after bad things happen. The digital twins are very important before the bad things happen. So you know exactly what you've got, because a lot of these structures and the utilities, they're not brand new. They've been there for a while. And the original plans may not be around. The original people that put these things in, that had that institutional knowledge of them, they're not there anymore. So by archiving it, you can very quickly reference back to it and see exactly what was there, exactly what's damaged, and exactly what's going to be needed to repair it as fast as possible, to get everything back running as fast as possible. It's important that the data is then generated into reports that can be shared with all stakeholders. And that's very important as well. As when you start siloing the data and the right people don't see it because they don't have access to it, or the report hasn't been generated and passed along, then what use is it? And we have a tendency to silo our data and silo our information to where it starts, getting very difficult to attain, through whether it's through IT networks that are worried about security, whether it's not knowing who needs it. That is a really important part of this. All right, slide 7, access to data. Data management and access is, of course, challenging as well. Collecting the data may be easy. Having access to the data in one repository for all stakeholders to access can be a challenge in itself. We've kind of talked about that already. If a worker in the field doesn't have access to the data being collected and analyzed for the particular asset, then really how useful is it? That's obviously a challenge. So we as an industry, we have to empower our personnel to have access to this data. We have to figure out how we can, design those IT networks to safely allow those who need the data to get it. And of course, the goals are to make all these jobs perform better, improve the health of our assets, speed up emergency response, maintain regulatory compliance, and data should not be on hand. Should not just be in the hands of the data collectors, the data generators, but also those who need it. I know we're getting short on time here a little bit. I've been talking a lot. So last one, return on investment. The return on investment is huge. First of all, safety. Kind of hit that pretty hard in this presentation, but anything we can do to make people safer in the long run is better. And sometimes the optics we can use and the angles we can get at the same time keeping people safer may even be better. Taking the human element out of it sometimes is a good thing. Kind of like self-driving cars, they still have problems, but overall it's better. So kind of the same thing. Asset health, of course, that's another one. We need to detect failures in advance and maintain the systems and make sure that we're catching things before they happen. Very recently, I was shown a photo from a transmission system where there was a shackle that they found that was almost ready to break. And they were able to fix it before the breakage in a controlled manner with very little downtime. Imagine in a transmission system with 500 kV that all of a sudden this shackle breaks, and it was close. And then now you've crossed phases, you've tripped fuses and switches, and now you're down for a long time. And that's never a good thing. Efficient productivity, efficiency is always a thing. Whenever we can capitalize on efficiency and make things smoother and better, it comes back to what I said originally. We have to be good stewards of our customers' money. They're investing money to buy our product, and we need to make sure we give them the best product possible. Compliance, data collected during inspections creates a database for auditing purposes. Compliance is a huge return on investment. Environmental compliance. So there's a lot of things in the environment that this helps as well. Putting a drone up, less fuel in helicopters, less fuel in bucket trucks, longer battery time in the air is less carbon emissions on the ground. So it's always a good thing whenever we can help the environment as well. And then planned responses. Robots on site allow better data collection, leading to situational awareness prior to arriving on site. So when we can have these automated systems that can tell us what's there, as people are going to fix it, we've already collected the data with these automated systems, and we've already seen exactly where we're at and what's happened. So that's the last slide. So and this is quick. Yep. I know it was a huge overview. Went fast. I apologize, but I had to cram it in. My timer was clicking in front of me. So
yeah, I think Jim, you covered a lot of things that usually people who are into utility, they will think about. They'll take something out of this. We'll just quickly jump on to questions because we're running short of time right now. So let me just read out a few questions. All right. Someone is asking, what are some regulatory compliance benefits? That is one question. Jim, if you'd like to take that up.
The regulatory compliance benefits was the question?
Yeah.
With that, preventing safety incidents. Frequent automated inspections can ensure that employee safety and prevent dangerous incidents from occurring. The maintenance side of this is huge. So when we have the regulatory compliance, regulatory authorizations and compliance, actually two different things, but kind of connected. We can comply with the needs of what the services we have to deliver, and automating the process with the compliance on the regulatory side assists that as well, of course.
All right. Next question is, what is the average timeline for creating an automated inspection program?
Wow. That's a moving target because there's so many variables in there. It could be a few short months up to a year and a half to 2 years, because the regulatory side of this, getting the approval to run these autonomous systems, all happens through the FAA in the United States. the FAA and the regulatory bodies. So that's probably the biggest challenge. Our technology, our industry is certainly outpacing the regulatory side, just the speed of government, and I'm sure it's that way in every country. But the speed of government, making sure that the industry stays within their lane, because you got a lane, you can't go too far outside your lanes, and we certainly need to make sure that everything is complied with very well. But that does slow things down at times. But it's not a bad thing. In the end, it's a good thing. We get anxious when we see the technology, want to implement it right away.
Right. All right. There's another question. E. Vandelios is asking, I am wondering how an automated system react to or manage potential loss of control induced by high voltage interferences of a power station without any human monitoring.
So we've had very good luck. We've been flying these aircraft around electrical substations for years now, and it is extremely rare that we see any problems whatsoever. There are times when if they get really, really close, almost touching, sure, yeah, there's problems. But the early drones in our industry definitely had a lot more interference and had a lot more issues with magnetic fields and RF signals and things like that. But in today's drones, we just don't see it. I haven't seen any problems around cell towers or electrical substations in many, many years. So it's really almost not an issue anymore.
Oh, all right. Robert Ford is asking, how do you manage scale? I'm working in an area of 125,000 miles of lines, a million poles and towers, and an annual requirement of 200,000 pole and tower inspection ranging from 13 to 400 images.
Wow, that's a lot.
Yeah.
That's a whole lot of automated boxes and stuff.
Yeah.
So a lot of things, we have to be worked into that scale. One is how much distance do you have from the box to the range of the aircraft? We're still dealing with RF signals right now. There's technology where we may be switching over to cellular technology for these, but right now we're still on RF. So there's limits to the RF, and there's no set number on that because there's a lot of factors in that, whether you've got trees in the area, other things producing RF signals that, while they may not directly interfere with the aircraft, they certainly can reduce the range you're getting out of the aircraft. So you've got those to contend with as range issues. So now that in that scale thought process, how many boxes do you need? Because now, depending on factors, you may be getting the boxes closer and closer. So that's one aspect of it. Second aspect is once you complete a mission, then the aircraft has to come back and recharge. Most of the current technology is it comes back, recharges in the box. So now you're down for 45 minutes-ish, depending on the system, between flights. So what happens in during that 45 minutes? Do you have a second box with another aircraft that's out at that same time? So now you got 2 or 3 boxes at a single location to keep that going. So you got to figure that into scale. Is it better to have multiple boxes, or do you put more boxes spread out and run fewer missions? So scale can be very difficult. Just takes a lot of analyzing and really analyzing the needs. How often you need the inspections is a huge factor in that. Does that need to be that area need to be inspected once a day, once a week, once a month? And so there's no good answer for that other than you really just got to look at your needs and start looking at the performance of the box to work in the scale. And a big, depending on how big the scale is, sometimes, automated drones may not be the perfect solution at this point. Maybe manned aircraft is still a better solution. We're certainly working to where the automated box system is going to be the solution. But there are certainly scales where there are limits to the physics, we have right now.
Right. Thank you, Jim. I think that was a fairly elaborate answer. I hope, Robert, your question was answered well. Yeah. All right. I think that's it from the Q&A side. If you would like to interact with Jim, I think you could feel free to reach out to him over his email and connect with him over LinkedIn. We also have NestGen community, which we are releasing. So you can join the waitlist. I've shared a link in the chat. NestGen community is a community of experts, enthusiasts, everyone in the autonomy space coming together as we did today in NestGen, but for a long-term and a more inclusive manner, right, with the community. So please do join the community. You can check it out. And thanks a lot, Jim and Nathan, for joining us today. It was a really great session, and I think a lot of people will go today with some great insights on how to perform utility inspections with docks and drones.
Great. Thanks, everybody. Take care.
All right. Thanks. Have a good day. Bye.